Right now, an invisible digital dragnet is completely surrounding me. It doesn't use the internet, it doesn't care if my phone is locked. It requires absolutely no cameras, yet it knows exactly when I move, what devices are in my pockets, and how to silently manipulate the electronics around me. We see headlines constantly about massive data breaches and global tracking infrastructure, but the reality is much closer to home. If a modern-day threat actor wanted to isolate a target or try to harvest their credentials, they don't need a massive server farm. They really just need to slip a few tiny, unnoticeable devices throughout a building. These 4 identical pocket-sized devices are built to work together as a synchronized independent wireless swarm. Using a private silent radio link, these nodes work together to form a self-organizing collective hive mind. Today, I'm deploying this 4-node swarm right inside my private test environment. I'm going to show you the terrifying reality of what happens when malicious hardware stops acting alone and starts working together. Let me show you how it works. This is the BLEShark Nano, and what it does is it actually runs a multi-node mesh network called Shiver. So if we open up the Shiver menu right now, we can just go over to the dashboard and see that we're connected to 3 other devices, 1, 2, 3. So just as a quick overview, this is one of the things you can do. We're just going to send a message to our other nodes. So we can send a chat. We're going to send a chat to all of our peers, and it's just going to say something like, let's just say hi, and hold center button to send. And then we'll notice these guys are going to pop up, boom. They've all got their own little message right there. You can't see because the brightness is really high. So we just sent a message to all of our other nodes using solely one of these devices. They're not connected to our network, they're just connected to each other. Now, because this entire Shiver network is acting as a single device, we can do some really interesting things. So we can run a command on one of the devices and not all of them. So let's say we want this device to scan for nearby networks. We can toggle that one on, go to send, and then that device is going to go start, and it's scanning for networks right now. It's doing that all on its own. We don't need to touch this. It's very, very interesting how this works, and it shows just how powerful this actually can be at scale. So we can see that that device found 7 networks and then 2 other scanners because it noticed that the other 2 devices over here were potentially network scanners. So this can work as a blue team device just as easily as an offensive device. Instead of trying to force a single gadget to do everything, a threat actor divides and conquers by assigning specific role to each node. So Unit 1 would be the Scout. This device is set entirely to a passive sniffing mode to map out active devices and target networks. Then we have Unit 2, this is the Disruptor. This is programmed to deploy target-specific wireless disconnections. Number 3 could be the phishing trap. So this would be one that's running something like a captive portal that would try to force people to enter credentials into an open Wi-Fi network. Again, that's why we always tell people never ever connect to public Wi-Fi, and if you do, never enter your credentials into it. It's an extremely good way to have your credentials compromised. And as I had mentioned before, this is all within my own test environment. Never test anything that you don't have permission to test or own yourself. And then we have number 4. This is the Executor. This is the one that we're running just to control all of the other devices. The real danger here isn't the software, it's the footprint. They're really no bigger than a stack of cards. An attacker doesn't need to break in or mount massive antennas. They can slip them into a pocket, walk into a building, and drop them in plain sight behind a book, under a couch cushion, or next to a plant in under 60 seconds. Deploying a network like this takes less than a minute. Once they're placed, the hacker can walk completely away. They are completely off the building's grid, communicating through a hidden, untrackable protocol. First, the Scout node spots the target. Instantly, a command ripples through the mesh to the Disruptor node, which drops the target device off of its wireless connection. When the user checks their screen, they don't see an attack. They see what looks like a completely normal system update prompt or a login screen created by the trap node. The second a simulated password is typed in, the data bounces across the wireless mesh right back to the attacker's command station. But it doesn't stop there, because devices like this on a mesh network can actually be used to track people using the Bluetooth devices that are already in their pockets. Because remember, just about everything we have has some sort of Bluetooth. You've got headphones, AirTags, your phone, everything. These devices also have the ability to do a BLE spam, which will pretty much flood the airwaves with a bunch of BLE beacons, icons, and things like that, which effectively can stop your phone from working correctly, or just make it really, really difficult to connect to any of your Bluetooth devices. In the past, there have even been exploits that would crash iPhones just using BLE spam. And it doesn't stop there. These guys actually have IR, or infrared, so you could scatter these around and it could turn off TVs and other devices remotely from different rooms all over the place. You could effectively have these scattered around an environment and have it turn every single screen off in the entire place. And then play a segue to this week's sponsor, PCBWay. PCBWay is your one-stop shop for all things PCB design, manufacturing, CNC sheet metal fabrication, and so much more. And they're not just PCBs, they actually 3D printed me this absolutely gorgeous resin case for my Flipper Zero. And make sure not to miss out on PCBWay's 12th anniversary celebration. So no matter what your project is, PCBWay has got you covered. They've got engineers on staff there that help you every single step of the way. Thank you so much, PCBWay, for your continued support. You guys are absolutely awesome. All right, let's get back at it. It's absolutely wild what a mesh network can actually do if a hacker wants to cause some mayhem. And again, of course, we don't endorse any of these activities. We're just talking about what can be done and to spread the education and the knowledge so that you know how to protect yourself. 4 tiny blocks, 0 wires, and a mesh network that could effectively disable your corporate or your home wireless environment. It sounds like a high-tech heist movie, but it's clearly possible using technology and parts and devices that you can buy right off the internet. So how do you protect yourself? Well, first, acknowledge the fact that wireless is not private unless you make it private. Specifically, you have to be incredibly careful entering any credentials into any wireless or any network that you do not completely own or have control over, because you never know who's on the other line. Second, make sure your router is not only updated, but also using modern protocols like 802.11w to prevent easy wireless disconnection. Second of all, limit your wireless footprint as much as possible, because people can track you. Absolutely everywhere is tracking you right now, and data brokers sell that information to everybody for tons of money, and you really just don't want to be giving them more and more information about you and your habits. And I know how everybody loves AirTags, but those little things are supremely trackable, because that's kind of the idea. Devices like the Nyan box can not only locate AirTags, it can also emulate them, and they just added a feature that makes every Find My device in the area chirp, so it just makes it easier for bad actors to find things like your AirPods and things like that easier. I'm not out here trying to scare people. I just want everyone to understand that their wireless footprint is important, and minimizing that at all costs, I think, should be a priority. If you want to learn more about how distributed meshes handle secure pathways, leave a comment down below. Thank you so much for watching. You guys are absolutely awesome. Please make sure to like, comment, subscribe. That stuff helps me out tremendously. Stay safe, stay secure. We'll catch you in the next one.